when I did the phasor analysis for VAB, I came with I was very dramatic about it that day. VA minus VB, if you do it on a calculator, you will end up with A here, and this is root 3 times 1, because I used a magnitude of 1, and an angle of 30 degrees. So it's leading this guy. Now in your case, in other words, this guy is 30 degrees ahead of A here. Is that okay for you guys? Noah?
Yes, sir.
Okay. What I did here is, not I did, but this problem, that's one reason I picked up this problem. Your VAB in this guy is at 0. So what would your A phase be, knowing that this has to lead the A? If my VAB now, if this guy is now, let me use a different color. If my new guy, no, I'm messing this up. Let's go with this. This is my line to line voltage, right? Any questions on this?
No.
If I consider this to be my 0, where is this guy lying? Negative 30, right? All that you have to know is, if I have an A, and again, positive sequence, A, B, C sequence. As it is, you guys are having a hard time, so I'm not going to even ask you about the A, C, B sequence. You have an A, B, and C sequence. The line voltage, VAB leads VA by 30 degrees. So VAB leads VA by 30 degrees. So you have, now what I did here is, I picked my VAB to be at 0 degrees. So in order for me to still be leading by 30 degrees, this has to be at negative 30, that's all. But if you didn't get it, then I think you will get a fair amount of points, but going forward, you are going to just probably lose a bunch of points. So what I did here is, rather than making this as 480 volts with 30 degrees, I just took it at 0 degrees, which means my VAB is 480 angle 0, VAN is 480 divided by root 3 minus 30. I think this is 277. Got it? Alright, you guys are hiding your face. So my base voltage, like I said, there shouldn't be any angles associated with it. So I took my V base line to line, divide by root 3 to get a new V base, which is for line to neutral. So 480 volt divided by root 3, I get my 277 volts. And then to do my per unit, all that I have to do is, what is my actual unit? Well, it's 277 with an angle of negative 30, divided by my base voltage, which is this guy, I end up with 1.0 negative 30. All that is to say is, I should have, let me just take it one step ahead. All that means is, we are now moving into the per phase system, and we just reduce this guy, this entire V load thingy, to 1.0 with an angle negative 30 for V base line to neutral. And I made a mistake because they shouldn't have a And my per unit, V per unit, line to neutral, is my actual quantity, which is, this is 277. 277 with an angle -30. Base is 277 ohms. Per unit comes out to be, keep in mind per unit will have an angle 30 degrees. So I did discuss this. So we had a space, we had a V base, we found a Z base. Now we have to find the I base. By the way, the only reason I got into this line neutral thingy is because how the problem was written. They were interested in finding out currents in phase A. So not the, or the line current, in which case I have to find the voltage associated with the line to neutral rather than line to line. And the last part is pretty, just putting together everything that we just saw. IA per unit, or the line per unit, is the voltage per unit divided by the ZL per unit and the ZYP per unit. We just figured out the A to neutral per unit as 1.0 -30. Beginning of this problem, we figured out the load as a per unit, which was 0.043 with certain angle, and the Y to be 10 times that, so 0.43 with an angle 40 degree. And then this is just TI-89. I didn't bother to show you all the calculations. Now I have everything in per unit. So this is how much? 2. Sorry, this is per unit. No. So to come up with our actual base current, all I have to do is my per unit is actual quantity divided by base quantity. We figured out the per unit. We still don't know the actual unit, but we can figure out the base unit. So I base is what? We already have the S base here. The V base is 480. And if I do a √3 V base line to line, keep in mind this comes from, this comes from S is equal to √3 V line to line, I line, if you can remember that. So all that I'm doing is I base is S base of 3 phase divided by √3 V base line to line. 10,000 VA was our base, 480 volt was our 3 phase base. I add the √3 here. Out pops an I base, and this is my I base with a current of 12.03. So I base is actually 12.03. Now that I have my I base, it's still not my actual quantity. All that I have to do is, I have my per unit here, I have my I base here. If I multiply my per unit with my base quantity, I should get my actual quantity. And I have my actual quantity here. So base times my per unit, and here you go. So like I said, this looks very dumb when you're doing a small system like this. You're like, I could have done it in a much simpler way, and that's true. But once you have very large systems, it's very hard to figure out where you went wrong. It's quick and easy to find, okay, if my per unit is 2.147, does this look right for another similar system? And if it's looking similar, then you're like, yeah, this looks similar. And remember when we had this guy? We do it all the time. We look at the load, we look at the line. Think about this. The line should have as least resistance as possible. So you can't have a line which is like more than the load. Because this guy is an evil that we have to live with, but at the same time it shouldn't be very high. So that kind of quick check across the system we do all the time. That's actually all that I had. I mean, we covered a giant, not a giant, but a simple, we covered a decent looking one line diagram, and then we covered per unit. That was all that I had for today. Starting next class, we hit transformers. The first 2 lectures in transformers, you might take it a bit light, and that's fine. But right after that, there is 2 tests that come up. A short circuit test and an open circuit test. That's the crux of transformers as an engineer. If you haven't seen transformers during high school, that's fine, because I'm going to build it up from scratch. But at the same time, keep in mind, I'll probably just brush through a few things, not get into the electromagnetics of it, and get into open. I'm sorry?
We like the neck. The fun
We
part.
like the electromagnetics.
The fun part of the motor.
Oh, so the Maxwell equations and whatnot? Yeah, I can do that then.
I wouldn't mind going over that.
Smith charts.
Yeah.
Smith charts.
We have something similar to Smith charts, but not the Smith charts.
Yeah. Something similar.
Sad.